So here's the really important part of this lesson about how to factor binomials. What do you do if there are only two terms to factor? On the previous page, we couldn't factor that binomial into factored form. We could only find our key features in standard form. So let's do some easier examples of factoring binomials. We're still going to use our generic rectangle area model. We're still going to look for a GCF first if there is one. And there are going to be some parts of ax squared plus bx plus c that are missing. And that's okay, we expect that. For this first example, 5x squared plus 15x, I think my GCF is 5 because it will divide evenly into 5 and 15, which leaves me with x squared plus 3x. If I put my x squared here and I put my 3x here, that means that there's nothing to go here and nothing to go here. In fact, you can even just draw little lines through those because we're not going to use them. What times what makes x squared? Well, x times x makes x squared. And x times what makes 3x? X times 3. So my factors, well, I've got the length here. This is x, and I guess you could say this is 0 if you want to. So you could say that I still have the 5 as my GCF, but then my first factor for the length of that rectangle is x plus 0. And then for the width of that rectangle here, I've got x plus 3. Now, this is perfectly fine if you leave it like this, but really what we would do is we would write 5x times x plus 3. Because really x plus 0 is just x, and I don't need parenthesis around this. Let's try the next one. We've got t squared minus 100t. There is no greatest common factor other than 1 to factor out here, so I'm just going to write t squared minus 100t, and again I'm not going to use either one of these portions of the area model. What times what makes t squared? T times t. T times what makes negative 100t? That would be minus 100. So my factors here for the length along here would be t minus 0. And for the width here, it would be t minus 100. But again, nobody writes t minus 0. What you would see is you would see t times t minus 100. One more example. This is supposed to be a 54, not a 56. Sorry about that typo. Is there a GCF here between these two? Yes, and it's got to be negative because this first term is negative. So negative 9 is my GCF. And then if I divide that out of this term, I'm left with f squared. And if I divide negative 9 out of negative 54, I'm left with positive 6f. So I've got negative 9 as my GCF. F squared goes here. 6f goes here. What times what makes f squared? F times f. It really doesn't matter which variable you use. And f times what makes 6f? Well, I would say 6. So then I would write this as 9. What's on this side? I'm not going to write f plus 0. I'm just going to write f. And what's on this side? F plus 6. I'm going to leave these last two examples blank for now, but I would like you to try them on your own and then answer the question, what do you notice?